In this video, we're going to review some of the questions in your Chemistry Awesome Notes. So this one is taken from page 45. Now let's take a look at the questions. 3-methyl-2-pentene reacts with hydrogen bromide to produce P. Now the question is, name the type of reaction taken part and give the structure of product P. For B, show the complete mechanism for the formation of the major product of the above reaction. Therefore, overall, we have to find three things, which is what is the type of the reaction, what is the structure of product P, and the complete mechanism to produce product P. So to answer question A, we will start by identifying what is the type of the reaction. Now, since this is alkene, we all know that alkene will undergo electrophilic addition reaction. And then what is the structure of product P? Now you can start by drawing what is 3-methyl-2-pentene. So I have here 1, 2, 3, 4, 5. Pentene is 5. Okay, we have 5 carbon. And then 2-pentene means it is located at carbon number 2 and carbon number 3. So the double bond will be here. And therefore the rest you can fill with CH3. This one is CH2. This one is H. And this one is CH3. So this is your 2-pentene. And however, it gives you 3-methyl. So 3 methyls means this is, as you know, this is carbon number 1, number 2, 3, 4, and 5. And therefore, our methyl will be here. Now, this methyl will react with hydrogen bromide. Will react with hydrogen bromide to produce this product. Don't forget to consider the Markovnikov rules. So we have here okay, so if we look here, say this is carbon number 1 and this is carbon number 2. Our H will, of course, goes to carbon number 1 because it has one H here. So, our hydrogen goes here and our bromine will go here. But don't forget, once it is added, this bond will become single bond. So there you go. This is our structure P. So you will get the marks for the first answer and the second answer. Okay, so this is A. Now we proceed with B, which is to show the mechanism for the major product. So let's start. Okay, so we know this bond will undergo heterolytic cleavage. Both of the electron will be given to bromide to produce Br minus, and this H will be H plus. So the double bond, which is a nucleophile, will attack the H plus to produce this. So our H will go here. And as you can see, we have like 1, 2, and 3. So our carbon will become carbocation. Okay. Now you can directly actually choose this. So this one will attack this to produce okay. Oh, and I forgot. Once we reach this, we have to classify the carbocation, but this is already tertiary carbocation, so there is no need for rearrangement. It is already stable, and we directly go to the second step and we get this structure. So the mark will be given for this one, for the formation of carbocation, for the attack of bromine, and the production of the product. So there you go. This is the answer for question at page 45. Now for this one, this question, which is at page 58, I can say that this is a tricky question. Now I believe most of you, when I ask you to write what is the product, you might write like this. And then suddenly, when you want to identify which carbon for what we call this, for hydrogen and OH, and when you want to consider the number of H, you're going to bump into the same thing like this, and you get like, where actually H goes? Now, actually, the real answer would be this. The real answer is that the H will be here, H will be here, and your OH will be here. So why these things happen? Okay, now let's take a look at the mechanism. This question is asking us to write the mechanism for the major product. So let's start with it. Okay, so we have hydronium ion. Okay, so as we know, this bond will undergo heterolytic cleavage to produce water. Okay, to produce water, so I put it here. And this H will become H+, which is electrophile. And therefore, the double bond, which is full with electron, will attack it. And we are going to get this. So you can just add anywhere actually, or maybe we can just put it here and here. Now, this part, this carbon has 3 electrons, and so it will become positive here. Okay, and this is our secondary carbocation. Stop. Consider rearrangement if there is any. And if you look, yes, there we have, kita boleh buat what we call this rearrangement, which is 1, 2, hydride shift, which we are going to switch with this carbon. So we are going to get we're going to get this, and we get tertiary carbocation. carbocation. Okay, now this will react with water, where this part, this lone pair will attack the carbocation to produce so this one we have 1, 2, 3, 4, 5, and we have positive here. And for the last step, which is the removal, the production of alcohol, so we are going to react it back with H2O, where at this bond it will undergo heterolytic cleavage. Both of the electron will be given to oxygen. H will be hydrogen ion, and so oxygen will donate 2 of its electron to produce this. Sorry. Okay, and we are going to get alcohol, which is this one. So there you go. This is the answer for question at page 58.